In this video tutorial, functions will be explained. Functions are used to structure a program, so instead of writing one large program, smaller programs are written. This makes the program more readable, easier to update and modify and debug. To explain this concept, we will come to this program, which we did in an earlier session, current computation via Ohm's law. We will rewrite the program, but this time we will use functions. Before we begin, three things are associated to functions. 1. Function prototype, 2. Function call, and 3. Function definition. The function prototype means the declaration of the function to the compiler. So here we need to write a prototype statement, which is done in the preprocessor area before the main function. So here for our function it would be something like this. Now here, this is called the function prototype. This float means that the function returns one value, which is a floating point value. Current here is the name of the function, and the arguments here, we have two float, meaning that our function will receive two floating point values. So this is the function prototype. Next, we need to define our functions to be used in the program. We have two functions here. We have the main function and we have the sub-function called current. Now in the main function, first let us define the main function. Now the job of the main function is to input the values of R and V, then call the function current and send these values to that function, and then receive the computed value of I and then display it. So for this we need to declare local variables for this function here, and they are R, V, and I. So R, V, and I are local variables that can only be used within the function main. So first we need to input the values of R and V. Of course you can add text to the input. Now instead of calculating the value of I as we did in a previous session, here we will call the function current and send to it the values of R and V. But since our function returns a value, this function call must be included in an assignment statement, meaning there must be another variable like I which will receive the return value. So this is the function call statement, and finally we will output the value of I. Keep one thing in mind: when you write system pause, it should only be in the main function. Do not write it in the other functions, only in the main function. Now we will define our sub-function current. Now, as I said in an earlier session, any function is made of two parts: the function header and the body of the function. Now the function header here is actually a copy of the prototype. So if we go to the prototype, copy it without the semicolon, and we will paste it here. This is the function header, but still it's not complete, because here within the receiving parameters, these are variable declarations, meaning that we need to declare two variables that will receive the values of R and V. So let's say we will use small letters here, R and V. So the value of R will be sent and copied into the small r and likewise the value of capital V will be copied into small v. This is the function header, and this is the body of the function. In this body we need to declare one local variable, which is small I, which will contain the value of the computed current. Here we need to calculate the current using Ohm's law. I equals V over R. As you notice, I'm using small letters. If you use capital letters, you will get a compilation errors, because the capital variables are the local only to the main. Finally, we need to return the value of I to the function call, or to the main function, and in this case we will use the return statement, return, and then we will return the value of I. So the value of small I will be returned here to the main function, and it will be then copied into capital I. Okay, once we've finished writing the program, we can run the program and check the output. So we go to start debugging, and this is the output. So here the input is waiting for the values of R and V, so let's say 1012 volt, and the current value is 12 milliampere, and you can see this is a correct answer. Of course, you can also add text to describe these numbers. This concludes this tutorial.